All right, so today we're going to talk LLMs with my old friend Steve Su. And by the way, if you want to learn more about LLMs and how to build applications, how to use them in real world applications, come to the AI conference this September 26th and 27th in San Francisco, and details can be found at aiconference.com. So, Steve, welcome to the Data Exchange Podcast.
Great to be here, and Ben, it's great to see you. We have known each other. I think I want to say well over 10 years now. Yeah. So
more probably.
Really great. Yeah, great to chat with you.
Yeah. So Steve Su, and I will link to his LinkedIn profile, wears many hats. But now one of the hats he's wearing is a startup founder at a startup called SuperFocus.ai, where their mission is to build enterprise LLMs, and I guess initially focus on mitigating hallucination. So LLMs, super crowded, super active space. So why LLMs in particular, given your interest in physics, genomics, and God knows what else?
Yeah, so the origin story, I think every startup has an origin story. So I'll just briefly tell you the origin story of this one. I've been following LLM, so I've been following deep learning for well over a decade, and then more recently was following LLMs, transformers, all that stuff, with the advent of GPT, and also with some theoretical developments on things like word vectors. So I've been interested in that general area for 5, 6, 7 years, but I wasn't building anything. I wasn't actually, trying to use OpenAI APIs or anything like that until about a year ago. My co-founder, who is in Ann Arbor, which is about 45 minutes from here, he contacted me kind of out of the blue because he had heard me on some podcasts, and he knew that I did AI research related to genomics. He didn't really know that I had done anything or followed the LLM space at all, but he contacted me, and we started talking, and his original goal that he had been working towards for some time was to build an AI tutor. And I told him right away, because I had some theoretical grounding in transformers and language models, I said right away, well, I don't think most parents want a tutor that hallucinates, that doesn't give factual answers to the kid. Right? There's kind of a high bar if you want to turn over instruction of your child to an AI. I would say there's kind of a high bar, right? That's not the same thing as the kid using ChatGPT to cheat on an assignment or get some text that they can paste into their report. That's different. But a tutor is a kind of high value, high touch kind of interaction. So we started talking about it, and he started introducing me to building on the OpenAI platform. And I gradually convinced him that there were ways that we could solve the hallucination problem. But once we did that, probably the most valuable verticals to apply it to weren't necessarily education or building a tutor, but just in general, there are so many enterprise applications. Once you have the AI to the point where it's reliable, and more importantly, and as importantly, you can use what we call an attached memory. So the idea being that the customer has a corpus that they decide is ground truth. For them, it's ground truth. And we want to build an architecture that uses LLMs as a modular component, but we want to attach a memory to that LLM and force the LLM to source its factual information from the memory and not from the training information that gets encoded into its connections. We don't want that to be the main source of factual information. We want the customer-defined corpus to be the source. So that's how we got started. And this was pre-ChatGPT. So we were working on this, and then all of a sudden they launched ChatGPT, and we're like, wow, ChatGPT, wow. And we even had a long conversation with people at OpenAI, whom I've known for a long time, about this. And during the interim between ChatGPT and GPT-4 being officially released, their attitude in their conversations with us was, oh, well, when the model gets bigger and better, It just won't hallucinate. You guys are it's kind of cute what you guys are doing, but you're kind of wasting your time. Whereas our viewpoint, and I'll say a little bit more about this from kind of more of a mathematical perspective in a second, but our viewpoint was building a bigger model, but still continuing to use next word prediction as the objective function is generally not going to solve hallucination. It's going to make the problem a little bit better, but it's not going to fully solve it. And so this modular attached memory architecture, I think, is going to be necessary, at least for some time. And what happened is that when the GPT-4 official release came out, and there was that technical paper, which you probably read, there's a big technical paper. There's actually a graph in there which for a set of different knowledge domains looks at the rate of hallucination for GPT 3.5, ChatGPT, and also GPT-4. And of course, GPT-4 is better, but still the typical base rate for hallucination is still on the order of 10–20%. And there are many, many applications like call center support or reviewing documents, contracts, financial data. There's all kinds of places where you just cannot support a 5 or 10% or 20% hallucination rate. You need something which is 99-point-something% reliable on everything it says back to the human. And so that's the domain that our company is in. Our company is building actual real world applications, which are narrow. They're not trying to be everything to everyone the way that GPT-4 is supposed to be. It's really supposed to only be good at a narrow domain of things, but in that domain, it's 99+%. And so that's sort of our mission statement.
So I have good news and bad news.
Yeah.
So the good news is I agree with what you said about enterprise requirements around hallucination. The bad news is I think a lot of people are working on this problem on the startup side. So it's a bit of a crowded space. And many of them are probably using some combination of techniques, including the one you described. But for our listeners, Steve, first of all, I think most people know what hallucination is, but how do you measure it in an enterprise sort of application, and how do you know you're done?
Yeah.
I guess one of the things you described, having this attached memory, like I said, several teams are working on something like this, and to the extent that maybe the information is not available in the attached memory, it just says I don't know, kind of like search, right? So if it's not in the index,
yes,
search results. So is that basically the notion of okay, we're done, because when it doesn't know, it says it doesn't know.
So a couple remarks. One, the full solution that we're building involves an attached memory, and I like to describe it as memory because if you think of the analogy with the human brain, the part of your brain that does language and reasoning might be totally different than the region that stores things, stores memory. So that's
I mean, I think most people kind of understand that even in this retrieval augmented model, you need to have some sort of performant, decent language model.
Yes,
right?
Exactly.
Even if you're going to go to the memory. Right? So.
And in fact, our architecture uses multiple LLMs, which are tuned for different purposes. Within the big AI, there are multiple LLMs and attached memory and things like this. So it is a crowded space because everybody wants to solve this problem. They know this is kind of a gating problem for enterprise applications. It's even a gating problem for what Bing and Google are trying to do, because it's no use having it giving the AI the top search results if it doesn't stick to the information in those top search results when it's doing something which is more kind of search related.
And then there are attempts to address this somewhat on the UX level, where you go, here's the answer, here's how I came up with the answer, kind of thing. But going back to my question, how do you know that you're done?
Yeah,
if I'm a company, I give you my data, and then obviously we can hammer it with questions, but there's infinite number of prompts I can send this thing, right?
Yeah. So first of all, let me describe how we, in our early development phase, how we tested our product. And this has a little bit to do with the AI tutor question. So one of the things, you're a former professor, I'm a former professor. So
You're still a professor.
Yeah, that's right. I'm not a good point. I'm not a former professor yet. So, but so modern day introductory textbooks, and let's put aside textbooks in math or physics, but just imagine like you're trying to teach US history or neuroscience 101 or psychology 101 to a freshman. Those textbooks now can be actually 2,000 pages long. Okay, they're pretty big and mostly electronic. Now, kids don't even carry the books around. They just access it through their laptop. And so one of the things we did as a test bed for our product was we used the textbook itself, just a plain PDF, but then it's obviously it's processed by our architecture. But basically, as a starting point, the PDF for a given textbook is the corpus. And then we use as a test bed all the chapter questions that the professors who wrote that textbook prepared. So those are supposed to test you on the material. But beyond that, we even take another textbook in the same area and use its chapter questions as a test bed. And so when we said, when I say, maybe I'll say publicly, hey, we reached 99+% accuracy, what I mean is that on that test bed, our architecture can deliver, with below 1% error rate, correct answers to essentially all of these chapter questions that are related to the particular topic and using a particular corpus as its memory. And along the way, we discovered very, very subtle hallucinations. I'll give you my favorite example of the most subtle hallucination that we found. So in these introductory neuroscience, cognitive science, whatever textbooks, there'll be like a little bio about Sigmund Freud, okay? Because he's not actually that important now for modern psychology and cognitive science. And maybe another bio about like Carl Jung, okay? Now it turns out Carl Jung was an early disciple of Freud. So Freud was his mentor for a while, but then they had a big break. And they had a very, if you're interested in that kind of stuff, they had a very colorful relationship. And there have been novels and plays and all kinds of things, fictional things written about their relationship. The textbook might only include just a brief statement that Jung worked with Freud until this year, and then they had a break over their theory of the unconscious, only a few sentences on the relationship between Jung and Freud. But when you ask ChatGPT or GPT-4 or Bard or any of these guys about the relationship between Freud and Jung, you will get elaborate answers, which are often based on totally fictional information, which is somewhere in the training corpus. It's on the internet, right? So that's a very subtle thing that form of hallucination. And in our models, when you ask it, it will only give you the limited information which is in the core corpus. It'll suppress all of the fake stuff that it kind of remembers from its early language model training. And
Steve,
yeah.
There's a combination of, it sounds like there's a combination of automatic evaluation because you have access to these textbooks, which, by the way, for our listeners, is not dissimilar to how Google and OpenAI do evaluation, right? So whatever, they use bar exams or something like that, right? So there's some level of automatic evaluation.
Yep.
So what sort of human evaluation do you use?
Right. So in the evaluation of the results, I think the key issue is the following. What is the metric you're trying to beat? Are you trying to get, like, what do you mean by 100% correct answers, right? What you really care about is, does it outperform a human worker? Mm-hmm. So in other words, if it's a call center and you're trying to help people figure out how to like program their Samsung TV, surely the call center guys, I know from personal experience, make mistakes themselves. So the main issue is, can you measure the performance well enough of the AI? Like, I deliver this AI to my customer and they start testing it. The main thing is they have to be convinced after enough statistical testing that it's comparable or superior, or sometimes maybe way superior to the humans that they're employing for this task. So that's really the key metric that you care about. Of course, you have to develop a whole platform for testing, and you have to know something about statistics, and you have to know something about sampling. So you could say like it's commodity, anybody can build this, but actually when you get in there, you realize, well, it's also like building a trading platform at a hedge fund. Maybe everybody can do it, but the rigor with which you do statistical testing and sampling and evaluation of your strategy determines like whether do you really understand like how good your model is, or are you kind of fooling yourself? So there's a fair amount of actual, I would say, kind of highbrow sophistication you need to deliver the product confidently that your customer will love, right? So it's a little bit non-trivial. Now, I'm not saying, yes, there will be many startups competing in this space, but it doesn't mean all of them are going to succeed in building a really, excellent product.
So it seems like the test harness, you start out with some automatic tests, in your case, textbooks or exams or something.
Yep.
And then you have some level of human testing, and then some level of human testing in the wild.
Yep.
So one question, as you were describing that, Steve, is do you think that this will have the same kind of bar that people place on self-driving cars, in the sense that,
no,
theoretically speaking, you think that, okay, so I think theoretically I accept that self-driving cars make less mistakes than humans, but that one mistake that the self-driving car makes is memorable.
Absolutely. So we don't see in the near term as our customer anyone who's doing automated training. We're not trying to build a bot which actually trades billions of dollars for a fund. That's like the error, the consequences of errors.
Or even mapping it to the customer support, right? So yeah, I know theoretically the bot makes less mistakes, but the one time it made a mistake, I remember.
Well, okay, so the issue is how big is if you compute some expected value for the cost of errors, right? That's what's important. So if the guy cracks up in the car and you get a concussion or you're killed, obviously even if the rate is low, you have to multiply that by the consequence. And same thing with trading bots or something. But a lot of the places where we see value already in our pilot customers are places where a machine error is low cost to them. So an example would be, we work with some travel management companies. So let's say you're a travel management company, you handle the travel for Google, and you also handle the travel for a bunch of other customers. And you have some special rates with certain airlines that have been negotiated. You have certain policies about who can travel business and who can't. So there's a whole bunch of rules. And our AI is already actually superhuman in the sense that it can remember all the rules. And when the human agent, travel agent, asks a question like, oh, are Google Cloud employees allowed to do XYZ? It just answers them right away, pretty much correctly, right? And it gives them a little reference, like a citation. So it's already better than humans, because a human has to flip through some big man. Actually, they don't remember. They can't remember all the policies, right? So it's already superhuman, but if it makes a mistake, it's relatively low stakes. So does that make sense? So
in other words, as you deploy these systems, you have to also remember the context and the like you said, the expected value of the mistake.
Yeah.
And so, Steve, as part of the onboarding, let's say I decide to use Superhuman tomorrow. What do I need to provide? What are the integration points? You mentioned rules. Do I have to have a document of rules?
Yeah. So right now the solutions that we're putting out there are very high touch. It looks more like a consulting engagement than SAS just delivered, seamlessly, but it'll evolve from one into the other. So right now what happens is we're actually working with the companies that we partner with, and they're saying, this is our corpus. You guys can clean this up however you want to make it more understandable by the AI. There might be some engineer time to do that. They tell us what are the most costly mistakes that we really want to avoid. There's a whole bunch of process involved. Eventually, though, let's suppose the travel companies that we're working with, we get to the point where they're really happy with the AI that we're delivering. Then I think that is repurposable to many, many other similar companies, or maybe even major airlines, without a lot of hand tuning, right? So it's there'll be the amount of tuning required gets less and less and less.
Is it more travel as a domain or customer support as an application that's
very interesting?
The more transferable in terms of transfer?
Very interesting question. It really depends, because like for travel, it has to understand some concepts like time and dates and things like this, and that the traveler can't be in two places at the same time. There's some very key concepts that you have to do some work on the language models to make sure that they understand these concepts. Otherwise, it won't perform well. On the other hand, if it's more like I'm buying this lawnmower and there are only like about 100 questions that dominate the full space of what people ask about this lawnmower. Like, can it use this type of fuel? Does it have this safety feature? How big is it? Will it fit in the back of my car? We find that most of the space of interaction is very limited, actually. And so actually, if you just have your thing working in an environment for a while and you're carefully reviewing the human feedback data, and then you're tuning based on that, you can like kind of fully solve 99% of a problem space, actually sometimes with a relatively small AI. And then it's like, well, great, that is the AI for answering questions at Sear at Costco about this set of appliances, and it's just really good at that. And then like I challenge you with your billion parameter model and your $1 billion arrays. I challenge you to build something better for this narrow space than what we built. You won't be able to do it. Our thing will cover basically what all the humans care about in this little space, and it's basically runs with very little CPU load, and it's fast. Whereas your thing, who knows what your thing is going to say? If the person asks the question in a slightly colorful way, your thing might start talking about Robin Hood or something. Like who knows, right? Like my thing's not going to do.
So it sounds like what we're talking about really are these next generation chatbots that are much more capable, much smarter, much less prone to error. So architecturally, Steve, you alluded to having smaller language models. So I'm thinking, so you have a language model, I type a prompt, your language model tries to understand what I'm asking for. So the naive approach here is, okay, so I have a decent language model. I have a bunch of documents in a vector database. And then if the answer is somewhat in the vector database, then it returns, and then the same language model will summarize it. But it sounds like you guys are talking a lot more advanced here. In the sense that so there's two components to a language model, right? So there's the training it, and then there's the tuning it, and then there's the inference. So walk me through each of those steps: training, tuning, inference.
Now, I don't want to give away all our secrets, because as you say, like there are a lot of companies out there,
high level.
But I just want to give your audience a sense of the complexity involved in this. And you might say like, oh, why are you guys spending so much time on a bot that all it does is help people with their consumer electronics? Well, it's a pretty big business, right? If you could replace every call center worker in India who is working on consumer electronics things, it's pretty big economic value. So it's worth a good team of engineers really working hard.
And not only that, if this replacement can actually answer your question.
Absolutely, it's got to be well above the human.
I mean, because it does. There's nothing to. I'm not bad mouthing call center workers, but not all of them can answer my question, right?
That's my point. So if you found like the AI still is not perfect, but it's much better on average. It's like your best or your top 10 percentile call center worker. You're still going to swap it in, right? Over it's much cheaper too. So
training, tuning, inference.
Let me describe several things that are involved here. So first of all, as I mentioned before, we have multiple LLMs in the architecture. So the LLM that is good at doing the semantic search on the corpus may not be the big model that creates the generative content as a response.
And these are all your own LLMs?
No. So some of them might be like obviously if we could afford it and cost is not an issue, we might use GPT-4 as always the big model,
Right.
right? But the smaller models, like the smaller model that is doing the vector search and or maybe breaking up the query into logical subcomponents, that could be a smaller model. That doesn't have to necessarily be the big model. And you don't want the big model because there's higher latency. So you want to have like smaller fast models for certain steps of the process. But then like I don't think we can currently avoid having at least one powerful model in there for really generating the full-blown result. And then there's another phase, which is the error correction. So like the big model might propose something, but in some of our architectures, what it proposes is then further broken down and checked against the corpus before it goes out to the human. So that guy also might be a smaller, lighter weight model because it's only looking at maybe one or two sentences at a time and just kind of fact checking those sentences. So anyway, there's a diversity of ways. Yeah.
Let's make this specific. So in the travel agency use case, what kind of latency are we talking about in terms of response time? Are we still in the millisecond range? Or,
No.
one of my pet peeves with the LLM APIs is just they take forever, man.
Yeah. So one of the main engineering challenges that we're working on right now is trying to beat down the latency. And what can you parallelize and what do you need to do sequentially?
And what's because that affects user experience, right? So if I type something and then now I'm waiting 30 seconds, that's a very different user experience than milliseconds, right? So
absolutely. So all these things are super important and they require some engineering brain power to optimize and solve, right? And your team has to be constantly testing. Like if somebody comes out with Falcon 40B and they say, oh, Falcon 40B is really good, and plus it's open source. So if this customer needs it on-prem, you can use Falcon 40B, but you can't use,
with the right open source with the right license, which is key.
Right. But looks like Falcon 40B is very slow. Like one of the issues we're seeing with it is very slow. So then if you quantize it, how much can you speed it up? All of these things are the things like probably for your listeners, this is like their daily bread and butter. If you're one step out of the space, you don't know what I'm talking about, actually, right? So that's what all the teams at all these startups are trying to figure out as they engineer toward solutions which I believe will be narrow but highly efficient solutions. And you got to remember, once I get it into the particular customer, the interactions that it is having is we're going to use those to make it better and better. And I believe those interactions will be typical for many other similar firms that will become our customers. So eventually, we're just going to have a very lean, mean, optimized AI that's just really good at a particular task. But it might be the task that a human is actually performing all day long, hundreds of thousands of humans, and you're going to maybe replace them or make them 50% more efficient by giving them access to this narrow AI.
So when you say lean, mean, in my mind, I'm thinking I can deploy this only on even just CPUs. I don't even need GPUs.
Yes.
And then maybe presumably later on offline on a phone.
Yes, I believe so. I mean, I don't know what the limit of this is. So will like current GPT-4 performance be available on my phone with no internet connection soon? I'm not sure. Like Emil Mustak said something very aggressive about this recently. I'm not sure I agree with him. He said like within 1 or 2 years. I'm not sure about that.
But, I mean, that's general purpose, but in your narrow domain specific.
Yes, in the narrow domain, I believe that. But by the way.
But Steve, you still need, as you mentioned, you still need that kind of user-facing LLM to just parse the question. Yes. And then you pass it to your really slimmed down LLM. So that user-facing LLM might still have a minimum size, right?
Exactly. But the question is the following. Could you, and this is a theoretical question, I don't know the answer to it yet, but could you work on paring down that originally what was a big, powerful LLM, knowing ahead of time all the questions are going to be about consumer electronics? It's a very small subspace of all the queries that it could possibly get. And could you narrow it down without losing performance in that small domain? Could you do some kind of quantization which still preserves its abilities within a small domain? Like that's an interesting theoretical question. I don't know the answer, but I would be shocked if there aren't many orders of magnitude up for grabs, since people have not even only just recently started trying to win those orders of magnitude. I think we're going to get them if we try.
So I have 3 pet peeves when using these APIs. Okay, so
Yeah.
one is cost, and
Yes.
cost is going away because there's a lot of competition and it's going down. But it's not free, right? So when you come from my world of using open source libraries for free and you can hammer it as much as you want, now you have to think through, do I really need to do this? Because it's going to cost me $5, right? And then latency, as we mentioned, right? Annoying, super annoying. And then 3, brittleness, right? So, I mean, you put a comma, you put a different semicolon, it comes back with something completely different, right? And you can, I mean, I guess you can set the temperature to 0, but that's kind of insane, right? So what are you doing in terms of the brittleness aspect? Because in your case, right, so I asked a customer support agent a question, and then tomorrow I ask the same question with different wording. Well, I get the same answer.
Yeah. I actually feel that, at least for us, brittleness is not one of the top problems that we're irritated about right now. We seem to see pretty good consistency in the answers as long as the semantic meaning of the original human query is okay. Then we don't get like wild oscillations in quality of answers. Again, it could be because we're always in a pretty narrow domain that we're working in. As far as cost, I agree with you 100%. Like the competition with open source models, and also, like, as you know, like when the VCs are pouring money into all the foundation model makers,
they may be losing money each time we ask a question, right?
Yeah. So I see a period where we're getting subsidized inference, but then by the time that's over, we'll actually have developed the technical capability to have cheap inference thanks to open source models.
Yeah. What I tell people is, look, I mean, we're still in the early innings of this. Look at what happened in computer vision, all the tricks they applied, right? So distillation, compression, quantization. Now those things are running on doorbells, on cheap things, right? So
no, this is exactly, no, I mean, this is a great analogy, Ben, because not too long from now, when you go and ring the doorbell, it's going to start talking to you. Yeah. It's going to say, like, are you here to deliver a package? If so, do X, Y, Z. Oh, the master of this house has requested that you no longer do blah, blah, blah. The doorbell can actually have a fair amount of intelligence. It can see you and talk to you, right? It's going to happen.
So in your case, Steve, so one of the problems with chatbots from, let's say, circa 2-3 years ago is that you couldn't really ask them complex questions. So in other words, so the difference between some of these really bleeding edge language models and some that are not, the bleeding edge language models, you can ask them really complicated questions, right? So here's some data, do the following. Oh, and after you do the following, do another thing and another thing, right? So series of follow-up questions. Yeah. So in your case, your frontline user-facing LLM, what kind of questions am I allowed to ask?
Yeah, so we're actually, I mean, a big part of this, and again, this goes into the category of engineering for the problem, is we're not really trying to address use cases where the queries are that complicated. We're looking at situations where the queries are kind of like simple to moderate complexity, but the thing gives very reliable answers and based on a customizable.
But there's notion of follow-up. So for example, in the travel thing, right? So I want to go from here to Copenhagen. Oh, and by the way, if that's not possible, I want to go from here to you know what I mean?
Yes. So I would say let me put it this way. So obviously having it hold some state and being able to actually quote chat about the travel planning is important. That's something that we're building But like the very first applications are generally aiding a human agent who's helping a customer. So that it's not just the AI talking to the customer, it's the AI helping a human, but the human can't remember all the complicated stuff, or the AI surfaces some things for the human that are useful, the agent. The next step, which is a big leap, right? The leap that puts out of work 90% of all human travel agents, that leap is going to take a while. I don't know when we're going to get to that point. And remember, like, I don't know if you have this experience, but sometimes when I deal with a human travel agent, I realize they're very suboptimal. Like while I'm talking to them, I'm searching things on Google and Kayak, and I'm finding like they don't give the best. I'm like finding better optimal solutions to my constrained travel problem than the human. So, there's going to be a period where you have AIs, that are fallible but they're trying to help people. But it's kind of similar to the current situation, except that it's not a meat-based fallible guy helping you. It's a silicon-based fallible guy.
I only travel Star Alliance because I have a lot of status. So I only go to the United website, Steve. So there's not a lot of options.
Is that true though? I mean, what if you have to connect to some Ryanair flight in the middle of Europe to get from Madrid?
Well, there I call United. Yeah.
Oh, you call United. Okay.
Yeah.
But then you're talking to United Human, right?
Yeah, but if you have status, they will pick up. Yeah. And they will treat you nicely.
Okay. No, they're nice, but sometimes they miss like if you're actively researching it on your laptop while you're talking to them, you realize they're missing stuff that you can figure out, right?
Right.
And by the way, it's much more than just the plane flights. Like there's all crazy stuff, like if you're traveling on corporate business and you cancel a hotel room, what happened to the VAT tax that was paid? And there's a lot of, if you actually talk to real travel agents who are doing this kind of high level support stuff, there's a lot of complexity in their work. Like, what do you need to do? What do you need to submit to get back the VAT on the blah, blah, blah? And the rule is different for every country. No human can do that as well as the AI. The AI can like just give you immediately, like, follow these 3 steps and then you're done. The human can't remember all that. So
one quick tip for you guys on messaging.
Yeah.
I think what you're building is actually super interesting and can replace a lot of frontline routine knowledge work. So I would lean into this aspect and not emphasize too much hallucination for the following reason. I think hallucination will be a confusing term which everyone will claim they have. You come from security. It'll be like everyone saying, we do penetration testing or
right.
So when you go somewhere, everyone is doing hallucination, right? So they claim. So I think the fact that you guys actually are building an application that is an actual full-fledged solution, I would lean into that. And hallucination is just one aspect. I wouldn't put that front and center.
I think that's good advice, Ben. I think that this area is evolving so fast.
So much noise. Yeah.
But when we first started, and I gave you that OpenAI anecdote, which is 100% true. 6 months ago, a lot of people didn't know what hallucination was. And if they did know, they thought, oh, well, the next big good model will just solve it. So like that, at the time, that was a key conceptual point. Now I agree with you. Everybody knows about hallucination. Everybody claims to solve it.
There's 2 things that everyone claims, right? So fine tuning and hallucination.
Yeah.
So I think that if you only say that, then you'll get lost in the noise.
Yeah. One of the things I can tell, as somebody who's kind of an expert in this area now, I can tell who doesn't really understand what's going on when the claims they make about what issues can be solved by fine-tuning versus retrieval augmented, generative results. For people who are in there, you can really see the difference between, well, what can this accomplish? What can that accomplish? But in the marketing communications of a lot of companies, you can tell they're just full of shit, because they might claim like many more things can be solved by fine-tuning than can really be solved by fine-tuning, or they might misunderstand the difficulty of doing really good retrieval augmented generation. So you have to be in there to actually see what's possible and what's not possible.
Yeah. I think I would lean in on the whole notion that you're basically reinventing chatbots almost, right? So from the ground up for
Yeah,
for for this
in a
new
way.
wave of technology, and
Yeah,
then these chatbots will be more capable, um, less likely to make mistakes, and basically highly customizable.
yep, exactly.
Uh, and and uh, and then obviously, so many enterprise features you guys need to address if you really want to go to enterprise, right?
Yep.
Whatever they might be,
One of the
scalability. I mean, we talked about performance and efficiency, and then obviously the safety, security, ethics, integration, right? So
one of the things that
integrating with their own IT systems and things like that. But I think having a few of these pilots and use cases where you can refine the offering and figure out what you can actually automate somewhat would
yep.
be, uh,
I think you're right in saying that in a way what we're doing is making kind of a better kind of LLM assisted chat.
assistant. It's
Right.
assistant, right? So
But
intelligent assistant, right?
beyond that, though, we're not currently building this, but we can see that it's buildable. Is you can do a little better than that. You can actually, instead of an assistant that helps you based on a query, you can have a heads up display where you are trying to help somebody else, but the AI can hear what you guys are talking about. And then it's just automatically putting up information on the heads up display, which is relevant. It's kind of guess how it can help you, and then it's showing you stuff. And we're already kind of at that level where it can be looking up stuff in the corpus saying, like, I think this is relevant to what you guys are talking about. Is that useful? Is that useful? Click for, so you could have like some kind of heads up situation where I'm trying to help you, Ben, do something, and my AI friend is like assisting me, but in real time and without prompting. It's just assisting me based on what it's hearing you and me say to each other. That's very buildable. I think we're not building it yet, but I can see that it's buildable.
I think, Steve, the other thing that you guys really need to probably focus on is just uh, ease of onboarding and ease of integration, ease of use. Because
Yeah,
basically, if it's consulting heavy, the danger for you folks is someone will have something less capable, but
yeah,
easier to get started on.
yeah, yeah.
Yeah.
I think the key thing now is that everything in this space, if it's really enterprise focused, it's pretty much hype dominated because there are very, very few instances where a highly polished, really useful tool is being used at scale, which is employing LLMs. Like we're still really at just the beginning of this. And so, yeah, once we figure out how to do it, of course, then making it easy to onboard and, very light touch. That's obviously the next design goal. But actually, to be 100% honest, we're still in the place where we're trying to get the thing to be superhuman in quality, easy to use, low latency. Those are difficult challenges, actually. They're not easy challenges, despite what people claim.
So you talked about the pre-ChatGPT era. So
Yeah,
one key thing that was happening in the pre-ChatGPT era was the rise of this next generation enterprise search companies, which were, doing the combination, basically hybrid search, right? So BM25 plus neural embeddings, neural search.
yep,
Um, so a lot of those companies now have pivoted to, okay, so we're going to have a chat interface as well, and we're going to leverage these technologies. So I could see them being a source of competition for you. Now, they're not as focused in terms of hallucination quality and things like that, but the one advantage they have is that they can go in, point to your data, and then start giving you value. So
yeah,
that's one thing I would caution, Steve, is you can't be overly perfect because you might lose that first mover advantage, right?
yeah.
Someone already has the account, right? So
It's a tricky question. So it really boils down to, like, in the particular use case, like say it's a private equity fund, they want to make their analysts more efficient. what is the rate of garbage, bad responses and latency, the other negative issues that they can tolerate, and they still are happy to have the product installed. And that's part of this kind of product market fit, that startups are the only ones who can solve that problem, basically by just engaging really tightly with the customer to see how they're reacting to the stuff you're delivering. So we're in that process right now.
Yeah. So one question I wanted to ask you is, since you're interested in genomics, right? So genomic data is just text tokens.
Yes.
So can you imagine an LLM for genomics that can start making noise in genomics?
Not so much, because first of all, in the first approximation, the real issue in genomics, the models themselves, the way that genes affect, the genetic variants affect phenotypes, is pretty linear. It's actually pretty mathematically very simple. And the main issue is just limited statistical power to really fully train the models properly to predict the phenotype. But once you have the statistical power, when the dust settles, the mathematical structure of the model is usually pretty simple. It doesn't have actually a lot of nonlinear interactions. So a lot of the power of a neural net structure is not necessary. It actually makes things harder for you to train the model. So I don't see that LLMs are going to cause like a sudden, lurch forward for computational genomics, just because of the nature of the problem.
So let's pivot then to physics. So now you're starting to see solvers.
Yes.
Right. So for nonlinear PDEs.
Yes.
I mean, in my mind, theoretically, okay, so it makes sense. You have the universal approximation property of these neural nets, right? So you can, with enough parameters, you can solve anything. So so are physicists paying attention to these developments?
Yes. So in very data-rich areas of physics, like say you're doing plasma physics and you're trying to make your fusion reaction as efficient as possible, or you're at the Large Hadron Collider and you're getting these crazy backgrounds with 1,000 jets of particles coming out. Those functions which live in these high-dimensional spaces, which describe that physics, I think are susceptible to deep learning. So given enough data, you should be able to train pretty good neural networks that actually capture, in some sense, the physics. Like, it won't be easy to read out what the causal rules of that physics are, but the network will be able to predict, the output.
Is this happening? Not yet.
Yeah, it is happening. So there's a lot of work being done on use of deep neural nets in physics right now.
So there's a wave of graduate students in physics.
Yes.
Who know deep learning.
Yeah. In fact, actually, I'll call your attention to, do you know what a neural tangent kernel is?
I think so, yeah.
Okay, so there's this work that shows a simplification to the mathematical structure of deep learning in the large width limit. So if you're training a network, but you take the limit where the width of the network is large, it's heavily over-parameterized. Then in that limit, you can prove formally some properties about the convexity of the optimization process and the properties of the actual neural tangent kernel in that limit. And the people who did that largely came from physics, some pure math, but physics and applied math backgrounds. And so anyway, there is a cadre of people coming more from physics and applied math who do know some things about deep learning and stuff.
No, I guess I'm more interested in physicists who are learning deep learning to do physics.
Yes.
And even prove theorems in physics. Is that happening?
Proof theorems, I don't know where that is now. I mean, actually, you probably know, like, Terry Tao is leading some effort on trying to prove theorems in mathematics using this stuff. Proving theorems in physics, I don't know. It's possible there are people doing that. I'm just not very aware of it. But in terms of practical use of deep learning to actually just approximate really complicated functions which appear in physical systems, that is definitely going on.
So in closing, your company hiring, not hiring? If hiring, what kind of people?
Good question. So for our projected burn rate, we just mostly completed our hiring, but obviously if somebody really awesome comes along, we're super interested in them.
Are you remote first?
Yeah, so the company is officially based in Ann Arbor, which is in the middle of Michigan. And we've kind of just, by the way the hiring process worked, we ended up with an almost entirely remote team. And we're a little worried about that. I'm curious what you're hearing about the efficiency of that.
I mean, for startups, when you're trying to, especially where you guys are at, where you're still trying to figure out what to build, it's nice to be able to go up to a whiteboard maybe and just kind of spontaneously start.
Totally agree.
Yeah.
We just had, during the month of June, we had the whole team together in Ann Arbor. We rented some apartments and we forced everybody to live in Ann Arbor for a month and meet every day. But now people have scattered again.
So what was you feel like that was very beneficial, right?
Interestingly, so everybody's feeling their way on this, whether you're Google or Amazon or Goldman Sachs or a little startup, you're kind of feeling your way on remote, the characteristics of remote work. And so we were very interested in this. So we kind of like did exit interviews of all our engineers at the end of that month. And we were asking them like, well, what's changed? How has this improved? What do you think is going to happen when you guys all go back to your homes? The common thing that we heard was people saying that the main thing is that we just know each other better as people now. So the barrier to me bugging Joe and asking him a question has now been reduced a lot. The actual communication's not that hard. So in other words, if like Ben, you and I have known each other a long time, if I just suddenly have a question for you, it's not that hard in this Zoom format for you to actually answer my question or even like put some code into the chat or show me your screen. And the actual quality of the communication once it starts is not that bad, even for people who are remote. It's more the intangible psychological and social interaction that allows you to be comfortable asking the question or knowing which person on the team to ask a question to. That part needs to be ironed out. If I were an optimist, I would say, oh, having spent a month together, we got rid of 90% of that problem. But I could be wrong. I would hate to learn later that some team where the founders were very strict and forced everybody to like, okay, 4 days, everybody's in the office a week or something like that, that they're just like kicking our asses because they're much better. It's possible.
Yeah, I think the one-on-one communication, as you described, is fine. It's the whole, let's pull 2 or 3 people into a conference room.
Yes.
That's lost, right?
Yes.
Yeah.
But the thing is, okay, like it's interesting because on my computational genomics team for my other startups, we have been remote for a long time, although we did all work together because a lot of those guys were my postdocs. So we did work together. The people are older and more mature. They're all PhDs and stuff. And I find our virtual interactions are very good. I can pull a couple guys in and brainstorm in this format that you and I are in without much loss, actually. So it really depends on the nature of the problem and the nature of the team.
Yeah. And the nature of the space.
Yes, exactly.
So this space, there will be fierce battles, let's say.
Yes.
As I imagine, yeah. And with that, thank you, Steve.
Yeah. Hey, great talking to you, Ben.